Hey, so I'm going to go ahead and get into the review that I gave you guys in class. There are two parts to this. One part is going to be the review from in class, and I also have some extra questions off of a second review that you didn't get a paper copy of, but I'm still going to go over some questions for. All right, number one here, the area of a parallelogram. There's the area. The height of the parallelogram is that. There's your area formula. Which of the following is the base? So I'm trying to find the base here. I'm going to go ahead and use that formula to get all this put together. Now, because I know what the area is, I can go ahead and use that information along with the formula. Now, in class, I simplified this down. I'm going to do it piece by piece. First, I'm going to look at the numbers, then I'm going to look at the variables. So, for instance, I know the area has a number of 64. I don't know what the base has, and I know the height has a number of 16. So then now it's just figuring out what is the base supposed to have. And that you're just going to jump over the calculator, pull that up, and you can see that dividing that you'll get 4. So that means that B is out and D is out. 4 is going to be our number that we're going to have for the base. I'm going to do the exact same thing, only I'm just going to do it for the variables instead. So I'm going to get that set up. Okay, so what I have here is the same thing. The area has x to the ninth power, so I have x to the ninth, and the height has x to the third power, so I have x to the third. Now, my only two options over here are I can have x to the third again, that would be for the base, or I can have x to the sixth, that would be for the base. Now, most people made the mistake of choosing x to the third to go here. Really, what's going to happen, because they think, okay, 3 times 3 is 9, but this is 3x's, and this is 3x's. That's not 9x. That's x to the sixth power. That's not what I'm looking for. X to the sixth times x to the third. When you're multiplying, you're going to add the exponents. That would be to the ninth. So that means that this is my answer. All right, so I went ahead and marked out this table. You don't really need to make a table for this to work. I went ahead and marked out the 2 there, the -2. I marked that out in class. I'm not going to do it with the -2. So what I've done is I've put that function into the y equals here, and I've pulled up the table, and now I'm going to graph some of the points from here onto that graph. All right, so I just graphed from -3 to and 0.25. That's this far point here on the left, all the way to 1, 4, which is this point here on the right, and I did all the ones in between. Got a nice graph. The y-intercept, you can see it right here, is going to be 2, so 0, 2, 0, 2. The domain, just like we talked about in class, because this continues on both sides of the graph, on the left side and on the right side, that's going to be all real numbers. And the range, because it can't go below 0, is going to go from 0 up on to infinity up at the top. So that's going to be my range. The asymptote, just to kind of remind you, the asymptote is the line or the value that you cannot equal or you cannot cross. So for instance, this function 2 times 2 to the x power cannot equal to 0 because it has an exponent with an x. So you can't equal 0 here, which means that the only number that you can't equal is going to be your asymptote. This graph will never get to 0. It will never go past 0. You will never have a negative number. Now what's nice about this is that all this information is always going to be the same thing. I'm giving you the answers to a question. The only thing that will change is the y-intercept. And you can pull the y-intercept from right here. It's your initial value, 0, 2. Whatever that number there is in front, that's what your y-intercept's going to be. All right, jumping down to 3. All right, so here for 3, I'm just going to identify some of the basic information real quick. You got your percent. You have 500 milliliters. This says decay. So starting amount, your decay factor to the x power. So starting amount's 500. That's pretty obvious. The decay factor is the only information you have to calculate. The percentage does not go straight into the function. Like, I'm not going to have a 12 here or a 0.12. That's not going to be correct. I'm going to figure that out by starting with 100%, and I'm going to remove, because it's a decay, 12%. All right, now doing that, I'm going to end up with, I mean, if you need to, you can pull up your calculator and calculate it real quick, but that would be 88% on here. That I'll change over to a decimal, 0.88, and now I have my equation. You are always going to have your initial amount here. The initial amount is 500. Then you will always have your factor, your growth, if it's growing, or your decay factor if it's decaying and you're subtracting, and then you'll have your exponent with x. Now, the way that gets put into your calculator would be whatever that number, this number, and then you would do the power sign x. So for instance, that would be, let me turn this back on, like that. That power key I'm finding right there underneath the clear button. So I just pressed it again there for you. Now this part B, how much of the original air is present after 19 breaths? So I'm giving you something to put in, and I want to know how much original air there is left over, so that's what you're going to get out. So I'm going to put in a 19, so I'll pull up here on the calculator, 19. So 500.88, there's my factor to the 19th power after 19 breaths. Enter 44.07. All right, moving on to the back. Scientific notation is not on the test, but I'll do it real quick here. This is just multiplication. That number times this number, 9.28. I'm multiplying the tens, 10 negative 6 times 10 negative 5. I'm going to add the exponents up. That'd be 10 to the negative 11. That's much easier than doing addition or subtraction. Moving on. All right, simplifying the radical. So that's going to be splitting up this 112. I'm going to go ahead and write down the perfect squares real quick. So that's up through 10. Basically, I'm just checking which one of these numbers, what's the biggest perfect square I can get out of 112. Okay, and I've done that over here on the side on the calculator. I tried 4, got 28, so that works. Going to try to find a bigger number. 9 doesn't work. 16 and 7 works, so that's probably the biggest I'm going to get, so that's what I'm going to use. All right, now that I have a number that I can square root, I'm going to go in and square root 16. That's going to square root to a 4, which means that 4 times 3 here on the outside is going to be 12, and 7 is left over in the square root, so that would be my final answer. Don't forget this 3 here, or whatever the number is. All right, number 6. All right, number 6 is going to be the last one I do in this video. I'll do part 2, and I'll cover 7 and some problems from the other review. Here, you know what y equals, so I'm just going to use that information to do a substitution right here. So I'm going to substitute what y equals into this equation, and I'm going to write that over here to the side. So, all right, so there's the substitution. That's where the y was. Now I've substituted in what y equals. At this point, it's going to be combining like terms, the -2 and the -1/2. So that would be -2.5 or -2.5. Now it's just solving this two-step equation, and that's not very difficult. So there's my work for solving the two-step equation. First step, subtract 6. Second step, divide by -2.5. X is 2. I'm going to use that information to go back to my original equations and figure out what y equals. All right, so here I've plugged 2 back into this original equation and got 5. Okay, so that's my first part. I'm going to finish, and I'll do graphing for 7, and then some problems from the other review I have, some extras. Okay, see you in part 2.